Forever chemicals in the water supply are becoming a huge problem, especially in the United States. Forever chemicals are unnatural substances that enter the environment and drinking water mainly through industrial waste disposal. These chemicals cannot degrade in the natural environment because of the strong chemical bonds. PFAS is a family of over 10,000 chemicals categorized as these forever chemicals. PFAS stands for per and polyfluoroalkyl substances. This image shows the chemical structure of PFAS. PFAS have been used since the 1950s and are used in a lot of consumer and household products. These can include consumer products, food packaging, nonstick cookware, textiles, mainly waterproof clothing, cosmetics, smartphones, carpet, cleaning chemicals, construction materials, firefighting foam, furniture, and hand soaps. A large amount of the population in the United States are affected by PFAS. PFAS are present in 45% of U.S. tap water and 70% of U.S. urban tap water. This image shows the distribution of PFAS across the United States, with the light blue dots being those that are above the proposed safety limit of PFAS in drinking water. PFAS are responsible for several negative health effects on humans. This can include decreased fertility, increased blood pressure, developmental problems in children, increased cancer risk, reduced immune response, hormonal disruptions, increased cholesterol, and a risk of obesity. Mitigation strategies for removing forever chemicals in the water can include activated carbon treatment, ion exchange treatment, and high-pressure membranes. One way to remove the contaminants from the water is through the activated carbon treatment, in which contaminated water flows through an activated charcoal filter, which absorbs these organic contaminants. This is the most effective way to remove PFAS from the drinking water. Ion exchange treatments are used as either cation or anion exchange columns. In the first part of this image, there is a cation exchange resin, which is negatively charged, which promotes the positively charged particles from the drinking water to attract to the negatively charged resin. And then in the anion exchange resin, negatively charged particles from the water are removed. This is because opposites attract. High-pressure membranes, such as reverse osmosis, can use pressure to force water through a semi-permeable membrane to remove the contaminants. Some large-scale solutions to this problem would include more research on the effects of PFAS in the environment, along with implementing more regulations on the use of PFAS, evidently leading to no longer using items containing PFAS. The implementation of these mitigation strategies we previously discussed will lead to a reduction of PFAS in the environment. To learn more about forever chemicals in the water, I would recommend looking through the EPA's resources or any of the other resources that I have used to create this presentation.